Hello friends, welcome to this fourth video in the series of MCQs. This video is going to be an MCQ on number theory systems. So make sure you are ready with your calculators because most of the problems needs the help of the calculator for effective solving of it. It doesn't mean that without calculator we cannot do the problem, but it can make our work a little more easy. So come on, let's get started. Problem number 1, which says if n of a equal to 24, n of b is 15 and n of a intersection b is 3, then what is n of a union b? This is going to be the problem on principle of inclusion and exclusion. So which says that by the formula of n of a union b is given by n of a plus n of b minus n of a intersection b. So using the formula, this a has been given as 24, n of b is 15 minus n of a intersection is 3, 24 plus 15 minus 3 makes it as 36. So the answer is going to be B, which is going to be 36. Next, the number of different two-digit numbers that can be formed using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All the 10 digits starting from 0 to 9 is there. What we want is a two-digit number. So this two-digit number can begin with any number apart from 0, because when you fill it with 0, this becomes an one-digit number. So 0 cannot take the first position. Apart from that, this first box can be filled using one of these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are going to be 9 ways in which I can fill this first box with. Now coming to the second box. This box doesn't have any restriction. So even if I am going to fill 1 over here, I can fill a 0. So 10 is going to be a two-digit number. So this box has how many options to get filled up with? It has 10 ways or 10 options in which we can fill this box with. So first box can be filled with 9 ways and second box can be filled in 10 ways. So totally this two-digit number can be formed with this and this. So total combination will be 9, and so whenever you have a hand you will have to multiply, and this is going to be 10 ways, so 9 into 10, so answer is going to be 90. But we see that none of the answers over here tally. Obviously this has to be 90, but like it must have been a misprint. So go for the concept, the answer is going to be 90 over here. Next, the number of permutation of the letters. Permutation. There are going to be two things. One is going to be permutation, the other one is going to be combination. What is the difference between permutation and what is meant by combination? Permutation means arrangements and combination means picking. Okay, when it is going to be arrangement, A, B is different from that of B, A. But when you are picking, you can pick A and then followed by it B, or you can pick B and then followed by it A. Both of them are going to mean the same. So when it comes to arrangements, the ordering or the positioning does matter. So you will have to be very careful over here. Okay. So now the number of permutation of the letter A, B, C, D, E, F, G containing the string B, C, D. So this 3 have to be like a block. You cannot separate it, and they can occur anywhere in the order. So out of this, let me make a single block of these letters. So let me treat this as one element. So in which case 1, 2, 3, 4 different elements and this one block together. So totally I have 5 elements. So in how many ways I can fill this 5 boxes with 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, so I can place B, C, D here, and then a A here, a E here, a F here, a G here, I can place A here, B, C, D as a single string here, E, F, G here. So this B, C, D can place anywhere, and apart from that you can have 1, 2, 3, 4. So totally 5 elements are here. So in how many ways you can place them? You can place them in 5 factorial ways. And what is going to be 5 factorial? 5 factorial is going to be equal to 120. You can use your calculator. There is a calculator exclamatory button which you can use to find the value of the factorial. So the answer is going to be 120 over here. Next, if in a course a professor gives 5 grades A, B, C, D and not E, it is going to be F fail. What is the minimum number of students who are required so that 4 of them are guaranteed to get the same grade? Okay, so this is going to be the principle of Pigeon hole. We know that by Pigeon hole principle, say suppose we have n number of pigeons, then we have only m number of holes, and your number of holes is going to be less and the number of pigeons are going to be more. In which case, if you are first allocating 1, 1, 1 in each, there will be extra because the number of holes are going to be less. So at least this one of the box will have more than one element or more than one pigeon. So this is going to be the case called as pigeon hole principle. In a generalized way, this statement, if you have the number of pigeons to be more and the holes to be less, then the least number of pigeons that can be accommodated in one single box is given by the formula n minus 1 divided by m. This is going to be the floor symbol, and then you will have to plus 1. This will give me the least number of pigeons in a hole. Now these 5 grades are going to be my holes. I want the number of students who can be filled with this 4, so that 4 of them are guaranteed to get the same grade. So the least number in one of the grades, at least 4 people must be fit in. Number of students is not known to me. That is, the number of pigeons is not known to me. In which case, what happens over here? N is not known, minus 1 divided by the number of grades, number of holes I have is 1, 2, 3, 4, 5. This 5 is known to me. Floor symbol plus 1 must be equal to, and I know that minimum 4 of them have to get the same grade. So least number of people who have to be filled in the same grade is going to be equal to 4. So make this 1 to the opposite side. So this gives me floor of n minus 1 by 5 to be equal to 4 minus 1. So that makes it as 3. Cross multiply this 5 to the opposite side. N minus 1's floor will be equal to 5 3's are 15. So what will be n equal to? N will be equal to 15. Move this minus 1 to the opposite side, so it becomes plus 1. So this floor is going to be the least value which you will get. So least value meaning you will have the minimum number requirement. So the minimum value or minimum number of students who are required is going to be 15 plus 1. So the answer is going to be over here 16. So the quantity which you need to keep in mind over here is, by pigeonhole principle, n minus 1 by m's floor plus 1 is going to be the least number of pigeon in any hole. So memorize this formula for your pigeonhole principle. So we are done with set A. Let us move with set B. In the generalization of pigeonhole principle, if the n pigeons are accommodated in m holes, then what is the relationship between the n and m? Okay, this is going to be not holes, this is going to be hole, H-O-L-E, hole. So the relationship is there has to be more pigeon and there has to be less holes always. Then only you can accommodate more than one pigeon in one hole. So n is the pigeon, n always has to be greater than your m. So this is the criteria. So the criteria is going to be D, n greater than m. Next, if root n is not a rational number, then n is going to be, you need square root of the number. Square root of 4 is 2, square root of 16 is going to be 4, square root of 9 is 3. All of them are going to be non-rational. So the only rational number will be equal to 2. So the answer, root 2 is going to be not rational. Then if the value is not rational, then n has to be equal to 2. Next, you have A divides B and B also divides A. So it's like one quantity divides the other. A divides B and B divides A. Then what is the relationship A and B have? A must be the same as your B. Okay, so it is going to be cardinality of A and cardinality B, not the singleton A and singleton B. Since we have been given modulus A, this is also going to be modulus B. Okay, so if A divides B and B divides A, then modulus A will be equal to modulus B. This is going to be your answer. The next one, the minimum number of students in a class, to be sure that 3 of them are born in the same month. Again, the minimum number. So this is again a statement of pigeon hole, and they are going to be born in the same month. So they are taking the year, and then in the year how many people are born in every month are going to be tallied for. So how many holes can be made? So the holes are nothing but the months of the year. So how many months are there in a year? There are going to be 12. So the number of holes are going to be 12 in nature. I don't know the number of people who are going to be fitted in each month. The number of students who have their birthday in the same month is not known to me. But what do they say? To make sure that 3 of them are born in the same month. So the least number of people who have to be there in the box must be equal to 3, they say. We know that n minus 1 by m plus 1 is going to be the least number of pigeons. In which case, what happens over here? This is not known to me, minimum number of students. So let me keep it as such, n minus 1 divided by m. Number of holes, number of months is going to be 12 plus 1 is equal to, how many of them have to have celebration in the same month? Minimum 3. So this becomes 3. Take this to the opposite side. 3 minus 1 makes it as 2. Cross multiply this 12. So 12 into 2 is my n minus 1. So this makes it as n minus 1 floor equal to 24. So the least number n, the floor value can be removed and you can get the minimum value as 24 plus 1. So that makes it as 25. So the least number of people who are having their birthdays in the same month, to make sure 3 of them are at least there, n is going to be 25. Only if you have 25 people, then minimum 3 of them can have their birthdays in the same month. Next, we move on to the next set of answers. A divides C, B divides C, and GCD of A and B is going to be equal to 1. Then what is going to be the relationship over here? Okay, A divides C, B also divides C, which means their product AB will also divide C. So this is going to be the property. Say suppose you are having 2 divides 36, 3 also divides 36. Okay, it goes 1 and then 16 makes it as 8, 18 times it goes in 2, 3 goes 1 and 2, 6 goes 2, 12 times it goes in your 3. So both of them are going to divide 36, and we know that GCD of your 2 and 3 is going to be equal to 1. In which case, if 2 divides 36, 3 divides 36, 2 into 3, what is 2 into 3? 6. So this 6 will also divides 36. So that's what we say, AB divides C. But you can see or check with the other one. If C divides A, what is going to be C? C is going to be our 36. 36 divides A? No. 36 divides 6? No. 36 divides 2? No. So the perfect answer is AB divides C. How many ways you can, how many different ways? 7 different beads can be arranged to form a necklace. So you have quantities like this, you form a necklace 1, 2, 3, 4, 5, 6, 7. You have beads connected and they form a necklace. So this is going to be a circular arrangement, and when it comes to necklace, whether you take it in the clockwise or anti-clockwise, that doesn't matter. Okay, so no distinction between clock and anti-clockwise is there, means the number of circular arrangement is given by n minus 1 factorial divided by 2. If there is distinction between clockwise and anti-clockwise direction, then the number of circular arrangement will be n minus 1 factorial. Okay, so if no distinction is made, now it becomes n minus 1 factorial. Number of b's here 7. So it is going to be 7 minus 1 factorial divided by 2. What is going to be 7 minus 1 factorial? It is going to be 6 factorial divided by 2. What is going to be 6 factorial? 6 factorial is going to be 720. Use your calculators. So divided by 2. Now this makes it as 360. So the answer is over here C, which is going to be 360. Next, if GCD of A comma B is 1, then GCD of KA and KB. GCD of KA comma KB will be equal to K times GCD of A comma B. This is going to be the property. Now I know that I have been given with a data that GCD of A comma B is going to be equal to 1. So on substitution, this becomes K times of 1. So the answer is going to be K, your option number B. Now identify the correct statement. LCM of minus 4 comma 14 is 28, minus 4 comma 14 is minus 56, minus 4 comma 14 is minus 28, minus 4 comma 14 is going to be minus 4. Okay, so first we need to know that LCM, least common multiple, whether you take it for a positive integer or negative integer, is always positive, So when it comes to this case, you know that the answer has to be 28, but we will go by rules like how to find it methodologically, and we will conclude if 28 is going to be the answer. So what you have is 4 can be factorized in using your primes as 2 into 2, and 14 can be factorized as 7 into 2. So what is going to be the LCM of 4 and 14? So LCM of 4 and 14 will be, the common factor is going to be 2. So 2 into, the left out factors are going to be 2 into 7. So 2 into 2 into 7. When you want GCD, you will have to consider the common factor alone. So GCD of 4 and 14 will be 2. When you want LCM, you will have to take the common factor plus the left out factors. So this is going to be 2 2s are 4 into 7, 7 4s are 28. So whether you have minus 4 comma 14 or plus 4 comma 14, the answer will always be 28. It will not be 56, it is not going to be 4. The answer is going to be positive 28. So the answer is going to be A. So this is the way in which we can find the LCM of a data. Now moving on to the next one. From a club of 6 men and 7 women, in how many ways we can select a committee of 3 men and 4 women? So 6 men are there. What I want is 3 men. In how many ways you can do that? 6 C 3 ways. Notice you are picking. When you pick, it is combination. When you arrange, it is permutation. Okay, picking means combination. 6 C 3. And there are going to be 7 women, out of which we want 4 women. So how can you pick 4 women from 7 women? So it is 7 C 4. So I can pick 4 women from 7 women in 7 C 4 ways. You want a combination or a committee of 3 men, and whenever you have the word and, what you will have to do? You will have to multiply. Or means you will have to add, multiply if it is going to be and. So take your calculators, work out what is going to be 6C3 and work out what is going to be 7C4. 6C3 is going to be 20, 7C4 is going to be 35. 20 into 35, that makes it to be equal to 700. So the answer over here is going to be 700. Next, if n pigeonholes are occupied by kn plus 1 pigeons, where k is going to be a positive integer, then at least one pigeonhole will be occupied by. So instead of your general statement n and m, we have in a generalized way kn plus 1. If you have kn plus 1 pigeons, at least one hole will have k plus 1 pigeons. So this is a general statement for your pigeonhole principle. So you can go with it, k plus 1 pigeons. Next comes among 30 computer science students, 15 of them know Java, 12 of them know C++, and 5 know both. You need how many students know exactly only one of these language? Okay, so from the Java combination of 15, remove the 5 who know both of them, and so you have a C++ combination who are 12 in number, and in this 12 in number also you know 5 of them are knowing both of them, so remove that also. So how many students know exactly only one language of them? Will be 15 minus 5 plus 12 minus 5. So 15 minus 5 makes it as 10, and 12 minus 5 makes it as 7. So 10 plus 7, so that makes it as 17. So answer is over here, C is 17. If LCM of two numbers is going to be 14 and GCD is 1, what is the product of the two numbers? We have a theorem which says GCD of A comma B product LCM of A comma B is the product of the numbers A into B. This is going to be the statement of the theorem. By using this theorem, we know that LCM of the number is going to be given as 14 and GCD has been given as 1. What they want is the product of the two numbers. So what is AB equal to? AB equal to 14 into 1. So that makes it as 14. So answer is over here. A is going to be 14. So we are done with this set. Let us move on to the next one. Next, the minimum number of person in a group, to be sure that at least two of them are born in the same month. Again the same kind of problem. Pigeonhole, minimum number is required. N minus 1 divided by M plus 1 is going to be the least number of pigeons. Okay, so N, I am not known how many persons are there, and I have the same month, so number of months in a year is going to be 12 plus 1 must be equal to at least two of them must be in the same month. So least number they have given us 2. So n minus 1 by 12, take this 1 to the opposite side, 2 minus 1 makes it as 1. Cross multiply this 12 to the opposite side, n minus 1 is going to be 12. Floor of it, so the minimum value of n will be equal to 12 plus 1, so that makes it as 13. So B, answer is going to be 13 for you. The number of ways in which 7 persons can be seated around a round table. Round table, 1, 2, 3, 4, 5, 6, 7 persons have to be seated. Unlike the necklace case where clockwise and anti-clockwise are going to be treated the same, in a table sitting clockwise and anti-clockwise will not be the same. So it is going to be exactly n minus 1 factorial. There will be no division by 2. Division by 2 will be taken only if there is no distinction between clockwise and anti-clockwise. So this gives me n minus 1. So 6 factorial ways. 6 factorial is going to be 720 ways. So answer is going to be B, which is going to be 720. Now next one is every positive integer n greater than 1 can be written uniquely as a product of, the fundamental theorem says every number greater than 1 can be uniquely written as a product of primes. So there is only one way in which you can express them as a product of primes, and that is an unique way for every integer greater than 1. If a prime number p divides a square, then p divides a, p does not divide a divides p, a does not divide p. Okay, a prime p divides a square. Say suppose a prime called as 3 divides a square, let me say 81. 8 plus 1 is 9, 3 divides 81, it's perfect. Does 3 divide a? What is a? A is going to be 9. Is it true? Yes. answer is P divides A. If you want, you can check for the other one. A divides P. Does 9 divide 3? No, it's wrong. A does not divide P. A is going to be 9. 9 does not divide P. This is wrong. P does not divide A. P is going to be 3. 3 does not divide A. No, this is going to be wrong. So the option is going to be P divides A. Next, we will move on with the next set. There are going to be 10 points in a plane, no 3 of which are in straight line, excepting 4 points which are going to be collinear. Collinear means lying in a same line. 1, 2, 3, 4. So they are called as collinear. The number of lines obtained from the pair of these points is going to be, okay, now the concept is for one straight line I need 2 points. So there are going to be 10 points. So how many such lines can be made? 10 C 2. So this will give me 10 into 9 by 1 into 2. This goes 5 times. 9 5s are 45 lines can be made using the 10. But this is going to be for all the scattered, of which no 3 of them are going to be in straight line. But there are going to be a case where 4 points are going to be collinear to each other. So if they are going to be collinear to each other, so 4C2 lines can be formed. So this is going to be 4C2. So 4 into 3 divided by 1 into 2. So it goes 2 times. 2 3s are 6. Now they are going to lie in a straight line. So they form only one single line. So one line can be subtracted from which they are going to have totally 5 lines. The number of distinct lines which can be obtained using this 10 points will be, you will have to ignore them because they are going to lie in a straight line. So this total number of lines which are going to be formed using these pairs will be 45 minus this 5 lines which are going to lie in a straight line. So this is going to be making it as 40 lines. So the number of lines which are going to be obtained is going to be C 40. If n pigeons are occupied by n plus 1 pigeons, then any one of the pigeon hole is occupied by how many pigeons? There are going to be plus 1 pigeon. So n holes are there, n plus 1. So 10 holes are there, but there are going to be 11 pigeons, means I can put 1 1 1 in each, and at least one hole will have 2, which is going to be the extra pigeon in the other one. So the answer is going to be 2 pigeons if there are going to be n plus 1 pigeons. A and B are going to be any 2 non-zero integer. Then the GCD of A comma B is, by Euclidean algorithm, the GCD of any integers can be expressed in a linear combination. GCD of any number A comma B can be expressed as MA plus NB, that is a linear combination of the integers, and this expression is not going to be unique. You can form different ways in which it can be expressed, but it can be expressed in a linear combination of MA plus NB. This is by your Euclidean algorithm. Now the answer is going to be MA plus NB, which is over here. Next, if A equal to QB plus R, then one more statement again from the division algorithm. What is going to be the quantity GCD of your A comma B must be the same as your GCD of your B comma R. This is how we work. Every time a remainder is got, the remainder is again divided by the quotient, and then you get the new remainder until you have a zero remainder. The last non-zero remainder will become the GCD. This is the way in which we have formulated our Euclidean algorithm and worked it out. So the quantity is that GCD of A comma B, because A is divided by B and then you get a quotient Q and then a remainder R. In which case GCD of A comma B must be the same as your GCD of your value B and the remainder R. So this is going to be the case. Where does it happen? A, B and B R. A, B and B R. Okay, here D. So the answer is going to be A comma B equal to GCD of B comma R, the quantity. If you want, you can just check it out. Say suppose you have a number called as 48 and I am going to divide it by 5. Okay, how many times 48 goes in 5? 48 can be expressed as 5, it goes 9 fives or 45, so 9 into 5, 9 times it goes, and 45 means 45, 46, 47, 48, it leaves a remainder 3. Now the GCD of 48 comma 5 will be the same as your GCD of your 5 comma 3. This GCD is also 1 and this GCD is also going to be equal to 1. So you can just verify by giving any numbers to it. We have the last set of values over here. In how many ways the letters of the word stress can be arranged. There is going to be repetition of words. So if we have repetition of words, then the number of arrangements will be equal to 1, 2, 3, 4, 5, 6. 6 factorial in a numerator for the different terms. Denominator has the repetition values. First S gets repeated 1, 2, 3. So 3 times it gets repeated, so divided by 3 factorial. The remaining elements are going to occur only one time, so it is 1 factorial, 1 factorial, 1 factorial. So this is going to be the way in which your 1 factorial, 1 factorial, 1 factorial for the distinct elements. The number of repetition will be 6 factorial by 3 factorial for S, which happens 3 times. So the total number of ways 6 factorial is 720 and 3 factorial is going to be 6. This goes 120 times. Answer is going to be D, which is going to be 120. Next, GCD of A comma B is 1. GCD of K and KB, we have already seen this concept. It is K times GCD of A comma B, and this A comma B has been given as 1. So it is K times of 1. Answer is K. So the answer is B over here, K. Every integer n greater than 1 can be written uniquely as a product of prime number. This is also the one which we saw in the last slide. Next, 36 pigeons are accommodated in 4 holes. Then the least number of pigeons accommodated in 1 hole will be. So the least number they are asking you, n minus 1 divided by m plus 1 will be the least number. So now they are asking you which is the least number. 36 pigeons are there and number of holes are going to be 4 in nature and plus 1. So this is going to give me 36 minus 1 is going to be 35 by 4 floor plus 1. 34 floor, how many times least it can go? It can go 8 times, which makes it as 32. So the floor of 35 by 4 is 8. And now you have a plus 1 outside, so the least number is going to be 9. So the answer over here is going to be 9. Okay, so you have seen now the various ways in which you can play with numbers in permutation and combination, pigeon hole theory, and GCDs and LCMs over here in your number theory. Have your calculator ready. Please be comfortable using your NCR and your NPR buttons. Make sure you are able to locate them easily, and then the factorial button. You can have a view of the easy tricks using our calculator video for more inputs on how to effectively handle your calculators. Happy learning. Keep learning. Thank you very much.